In my experiment, I'm going to test a theory that states that darker colors absorb heat faster than lighter colors. I will do this by using food coloring to color water and test which one is the quickest to evaporate. I put 100 ml, a fixed amount, in each 3 of these cups. I'm going to put in this one as well. And I'm going to put 10 ml with this. I'm going to use this to measure 10 ml of each shade of food coloring. And for this to be the same amount, I'm going to use 10 ml of water. This is going to be my controlled variable. I'm going to have 3 cups with different shades of food coloring. And I'm going to have the last cup with just plain water. I'm going to put them outside in the garden, which is right behind me. And I'm going to test every 3 hours. I'm going to measure which one evaporates more, and this is going to happen in a period of 2 days. I use this ruler to measure the amount of water in each one, and right now the ruler shows that each one of them is at 4.9 centimeters. I'm going to put the cups outside in the garden, and every 3 hours I'm going to put the ruler next to the cup, the same exact ruler. I'm going to put them next to the cup and see which one, I'm going to measure each one and I'm going to write it down on paper, and every other 3 hours, I'll make new measurements. At night, so dew doesn't come in these cups, I'm going to bring the cups inside, close to the windows, just so before I wake up the sun might come up and it will still come on the cups. I'm going to take them outside as soon as I wake up and measure them again. And in the last hour before I take them inside, I'm going to measure each one and I'm going to see which one evaporated the most. My hypothesis is that the darkest food coloring, which is the blue one, will evaporate the quickest and the most. The medium color, which is the pink one, will evaporate in the middle. Then after it comes the lightest one, which is the yellow. And then in my hypothesis, the control variable, or the clear water, is the one that's going to evaporate the least because it has no color affecting it. And I'm going to go test. Over here, I'm measuring exactly 5 ml from the food coloring. I'm going to put it each in the water. I'm going to put another 5 ml. And I have to dip it far in so there are no bubbles of air inside it, so it would be exactly 5 ml. This is something that could affect my experiment. Again, exactly 5 ml. Gonna put in the water again. And after this, I have to clean the syringe so this color doesn't affect the other food colorings. I'll have to rinse this as well, so when I want to clean it again, I'm gonna have to put more water. Now we made sure that we cleaned the syringe completely. As you noticed, it's completely clean without any blue. We also cleaned this, so the next time we put food coloring in to clean it, we just dip it in this. So no food coloring affects the other, and this is a variable that could affect our experiment if we did it wrong. Right now, this cup with the added food coloring is exactly as we measured it. .3 centimeters, and we're going to have to make sure that each one of these cups have the same amount, 5.3 centimeters, and then after that we're going to go and test. Now we're going to have to clean it so the yellow doesn't get affected. And as you notice, because the color is lighter, the water is less affected by the food coloring than the blue, which means the blue will probably evaporate quickest, as I said in my hypothesis. Now, as we filled all the food colorings with different shades, we're gonna put another 10 ml in this. So they all have the same measurements. And right now, I'm gonna measure the different cups, make sure if they're all the same measurements. And right now, all of these three are 5.3, and after we add the 10 ml of water into this cup, it's going to be as well 5.3, and we're going to take them outside, and we're going to put them, and we're going to test. Now each one of these waters are filled with food coloring except this one, which is a control variable, and we're going to test each of them from the same distance, and I have to put my eye level where the measurement is to test exactly. Right now, this is 5.2, and all of these three are 5.1, but that really doesn't matter, because what we're going to test is the amount that it evaporated. So we're going to decrease the number it evaporated from 5.2 and see what, like, the exact millimeters or measurement that it decreased from the original position, and we're going to test which one evaporates the quickest and the slowest. Right now I'm going to put all of the cups on the table right there in the garden. And it's quite warm outside, so the evaporation is going to happen quicker, and we're going to test which one finishes the quickest. So these are the 4 cups right now. We've kept them out for about 48 hours, and this is the last measurement that I'm going to take before I take them inside. It's getting a bit dark right now, so it's a perfect time to measure them before taking them inside. So the plain water right now is looking to be about 3.9. The rose water is 3.8 actually. The yellow one is 3.8, and the blue one right now is 3.7. So the blue one has been the one that's most evaporated, and right now I'm going to take them all inside before it gets dark.